So hi, hello everyone, welcome to Raaonline. This is Dr. Stevenson, your faculty for biochemistry, and in today's interesting session we'll be seeing about the properties of genetic code. Okay, so what do you mean by a genetic code? A genetic code is the one which you normally see in all your DNAs. Okay, so what are the different peculiarities or the different properties of a genetic code? That is what we are going to see it today. Okay, so the first property of genetic code, okay, it is called as degeneracy of genetic code. So what do you mean by degeneracy of genetic code? Any idea? See, there are 4 bases, right? GATC. There are 4 bases. Okay, these 4 bases can form a codon. The codon will have 3 nucleotide base. Okay, it could be A, U, G or something. Okay, so here it is 3, right? So if you put the calculation, if you put the permutation and combination, they can possibly have 64 codons. So how many amino acids you have got? You have got only 20 amino acids. Okay, say for example, you have a codon. Codon has 3 nucleotides, right? If instead of 3 nucleotides in a codon, if there occurs a single nucleotide and you call that single nucleotide as a codon, G or A or T or C, if a single nucleotide can be called as a codon, then how many amino acids can be coded by those kind of codons? If you put the combinations, it is 4 to the power of 1, that is just 4 codons are possible. 4 codons cannot code for 20 amino acids. Say if for example a codon has just 2 nucleotides instead of 3, if it has 2 nucleotides, okay, now how many possible codons are there? 4 to the power of 2. There could possibly be 16 codons. 16 codons are still not enough to meet the total number of amino acids, that is 20. See, you have got more number of amino acids, more than 20, that is around 24 amino acids, but still the 20 amino acids are universal. You got the point? The extra amino acids are seen in certain kind of groups, but these 20 amino acids are universally found. Okay, so that is why I am sticking on to the number 20. Now if a codon has 3 nucleotide bases, how many possible codons are available? 64 possible codons are available. 64 codons, out of these 64 codons you have 3 stop codons. Okay, what are those 3 stop codons? UAA, UAG and UGA. These 3 are called as stop codons. Okay, so if you subtract these 3 stop codons from those 64 codons, then you have 61 codons which can potentially code for 20 amino acids only. So the number of codons are much higher when compared to the number of amino acid. Okay, so this property is called as degeneracy of codons or degeneracy of your genetic code. Okay, so how this is being accomplished? It means what? There are more than one codon which codes for the same amino acid. Please know the words. There are more than one codon which can code for a same amino acid. Okay, so how this is accomplished? This can be accomplished by a special hypothesis called as wobble hypothesis. So what do you mean by wobble hypothesis? In wobble hypothesis, I will try to draw the diagram here first and I will try to explain it so that it will be easier for you guys to understand. See, if there is a mRNA, a mature mRNA, okay, so this mRNA is getting translated in your ribosome. Okay, now once it is translated means what? It gets identified by the specific amino acid, it will be identified by the specific tRNA. Okay, so I'll try to draw the tRNA here. Okay, now this tRNA, you call this as codon, right? You call this as codon. And how do you number your codon? You number your codon from, you start reading your codon from 5' to 3' region, right? So the numbering will be 1, 2 and 3. Okay, this is a codon and you find some kind of a sequence in the tRNA here. Okay, so instead of A you find U, instead of U you find A, instead of G you find C. Okay, so this is called as anticodon. Okay, now here see, in case of tRNA you start numbering the same from 3' region. So the numbering will be 1, 2 and 3. Okay, so what do you mean by wobble hypothesis? In wobble hypothesis, the third codon, the third nucleotide of a single codon will have a very loose connection with that of the first nucleotide of the anticodon of tRNA. The 3 will have a very loose association with 1. The first and second nucleotide of a codon will have a very strong association with the corresponding anticodons, whereas the third nucleotide of the codon will have a very loose association with that of the first nucleotide of the anticodon. Okay, this you call it as wobble hypothesis. So what is the significance of this kind of a wobble hypothesis? See, the significance here is that you change this third nucleotide with any other kind of a nucleotide, you still get the same amino acid.